Hello, good afternoon. My name is Sebastian Wieczorek, and I'm going to tell you a bit about transformative power of AI. I hope you like it. So, starting, I want to give you a brief overview of what SAP is doing. So the only thing that I'm going to say is we've been helping organizations run their business processes for more than 50 years. That's all you need to understand. Okay, when we're talking about AI, I think the discussion about that is a bit longer or a bit older than 1 or 2 years. But basically, we have been talking about AI revolutionizing all the way businesses are running, from automation in manufacturing, for example, in internal process automation when it comes to HR processes, for example, or other processes, to customer engagement, the way we're interacting with our customers, the way we're informing them about our product or providing them services with. And this is basically AI as a whole. Now, at the same time, we're talking about this great disruption that is happening and that has been showing in the public for, let's say, the last 1 year to 6 months, depending on how closely you followed it. And what has happened is that we have made significant advances on the technology. So we went from, you can see that here on the slide, we went from AI that is classifying things that it is interacting with, to AI that is generating information, for example, text, code. From supervised learning, where basically people have to label the information, tell the AI system under training, this is a dog, this is a cat, this is a manufacturing plant, to self-supervised learning, where the machine is supervising itself while training. From predefined capabilities, where you say, okay, I'm training something that is classifying images, and I train another model that is doing sentiment analysis, and I'm training another model that is doing time series forecasting, to emerging capability, one model being capable of doing multiple tasks or showing multiple capabilities at the same time. And in essence, going from narrow AI to broad AI, where you say, okay, with one model or a few models, you can achieve a whole variety of tasks very freely. And when you look at it, of course, the previous step that we had on AI, they're not going away, right? Statistics is still important, will always be important. I think we've seen that until, let's say, the 2010s. That was the predominant way people were thinking about AI. Then prediction became the new common. You've seen that a lot of things. For example, you all are using GPS systems that are predicting the best possible way to get from A to B, are becoming dominant in software industry, and a lot of application now embed this kind of capabilities. And now we're emerging into a new field that is adding one layer of capabilities. That's generative AI. So when we talk about what is making this generative AI so interesting, so let's talk about the self-supervised part that I was talking about. Self-supervision means that combines a couple of different technologies, but here in this example, for example, what the system does under training is it takes a sentence, removes one word from the sentence, and then tries to predict, forgets about what was removed, and tries to predict what was this word that was taken out. And you see that in the sentence, chicken lay, then it's probably X, a correct word. But of course, if the system is guessing it right, then it will, in the training process, it will be manifested in the model. If it's guessing it wrong, the system will retrofit in order to be closer to saying X next time. And at the same time, when you look at when they are tired at night, chicken lay, you would assume that is down, for example. So again, if the system under training would come up with this, then probably it would be manifested. If the system would not come up with this, first taking out this word, then it would retrofit. That's basically the self-supervised part. So you have when you look at it from an academic point of view, you label your data set yourself because you create the holes in the text, but you know what was the word in there. That's for large language models, how they get trained. So the system is creating these texts with white spaces and then guessing these, then creating white spaces for whole sentences, then creating white spaces for whole paragraphs, and in the end, the system, as we all know, is able to generate text based on inputs. Now, when we're talking about generative AI, there are a lot of different terms that are flying around. Foundation models, when we talk about that, usually we're talking about models that have been trained in this self-supervised fashion. Right? And a subsection of that is large language models. These are self-supervised trained models that are producing text, sometimes code, other languages, if you will, you could count into that. Then you have generative AI. That's mostly a subsection of that. So it's generating text. It's generating. Some models are generating images. Some are generating video. So it's not just LLMs that are generative. And you have capabilities that are generative, like time series forecasting that we saw in previous iterations as well, that won't belong to foundation models even. And then ChatGPT, just to make that point, that's mostly large language model plus some magic sauce. So just that we're here all on the same page. Now, I want to focus on foundation models. You can think about large language models because most of you will have that anticipation, but it's not just bound to that. It's also video, it's also audio, it's also other modalities. Basically, what is happening is we're doing this training once, and then we have a foundation model that doesn't need to be retrained anymore and can fulfill multiple tasks without being specially trained for it. You can fine-tune it, we could talk about that, but let's assume for a moment it can fulfill arbitrary tasks on that data it has been learned on. And the interesting thing for us humans is we can instruct it with natural language, usually. And that's a cool thing, because before, when we interacted with AI models, what happened was that we need to be a data scientist or developer to even interact with it. Now we can be us, we can interact with it, and we understand the output as well. It's human kind of interaction. And the second thing is we don't need a data scientist for every single thing, or you go to a data scientist and say, okay, I want to figure out what is this object that I'm showing to you and how does it relate to the other objects that I have in my catalog. And the data scientist would have come up saying, okay, you need 5 different models, one for cropping the background, one for categorizing what it is, and then one for similarity scoring. Now it's one model that is doing the whole chain, right? And you can use it in kind of text. You can see here as a writing assistant to answer your questions, to generate code. And what most of the people understand is the prompt engineering part. So prompt is what we put into the model. But of course, there are other techniques underneath that, like providing embeddings, providing additional context, so to say, in order to help the foundation model to get to the best possible answer. And there's also fine-tuning options, providing context that is then going to be embedded or encapsulated in that model as well. So there are different techniques to enhance the quality of the answers beyond just prompting it. Now let's talk about the limitations of it. When you look into large language models, for example, at the moment there's no notion of time and chronological order, which makes it, in some interaction, makes it hard for the large language model to come up with the right answer. Numbers and maths, I think we've seen some progress, but if you haven't done so, try to make it count things. You will see that there's something that is so smart in some areas. It's that even ChatGPT is surprisingly stupid when it comes to counting, right? Maths, same thing. I think we see the progresses, especially when you say, don't guess, but give me a step-by-step explanation for some mathematical equation. It's getting better, but in general also a problem. I think it's clear that training and operations requires high efforts in terms of costs, in terms of manpower. There's, let's say, we all know that there's the possibility of hallucination. I would phrase it a bit differently. When you interact with a large language model, it's always guessing, right? So there's not a mode when it's not guessing and when it's guessing. There's only guessing. And so basically what we call hallucination is when it's guessing wrong. When it's guessing right, everybody's happy, but it's the same thing as you go up to the random next person and ask, what do you think is the capital of Brazil? Most people will hopefully give you the right answer, some will not. Then what is it? Are they hallucinating? Are the others not? It's basically most of us are guessing. Most of the time this thing is also guessing. But there are areas of expertise where it's guessing very well. And then if it comes to narrow knowledge based on few examples that this model has been seeing, the chance that it's producing the right output is getting lower. Also, what you have to see is that when you train a model, it accommodates the state of information that it has captured when it was trained. So that's another issue, especially when you want to question it on recent events, for example. There's a lot of variation in the output depending on few differences that you put into your prompt, so into the questions you ask. And there's a lack of understanding how confident these models are, and that's because they're always guessing, right? So the confidence is always the same, but it doesn't help you in analyzing whether they're right or wrong. So here's an example. If you're fond of SAP like me, because I'm getting paid by them, you wonder who are the 5 founders of SAP. You ask that, and you see here, I think that's GPT 3.5 answer. It comes up with Hasso Plattner 3 times. Obviously, Hasso Plattner is one of the founders, but not 3 of the 5 founders. You see that these kind of quality issues we see even in texts that could be common knowledge, at least for SAP employees. There are also some risks associated that are not so technical, like lots of people who don't understand how these systems are working, are taking things for granted that are coming out of these large language models. There's a lot of question about bias and how to detect it. So obviously there's bias in every model, but it's very hard to detect and to quantify and to deal with it. There's ethical questions around misuse of these models, and there are lots of legal questions when it comes to IP, when it comes to copyright, when it comes to person-related data. And here on this slide, there are some examples, for example, of a model reproducing an image that it has been trained on, which obviously means that it's leaking person-related data that it shouldn't, right? And there are a lot of lawsuits going on at the moment. So it's also for companies and end users also at the moment very hard to say what is possible, what is not possible, because a lot of legislation that is there needs to be interpreted by courts now in these lawsuits. So what is SAP's approach to this generative AI? What we're trying to do is basically to understand all these challenges that I laid out and find a pragmatic way to embrace the models in the best possible way. We're therefore of course, using this generative AI in the context of business data and business processes, as I laid out, we are taking a lot of precautions in order to keep human in the loop, so we don't have automated decision making, especially on things that are concerning humans. That's part of our guiding principles, and we have a rigid process to determine for every AI use case that we're implementing that this is obeyed to, and a couple of other things. So we're publishing our guiding principles, also our policy and processes. If you're interested, you can find that published on our website. And of course, for generative AI, we don't make excuses. We're following the same rigid processes. That means that we're also validating the outputs, that we're minimizing bias and discrimination despite the challenges that we have seen. But let's keep ourselves honest. I think there are some open questions also when it comes to policy, but also to SAP's policy, but also when it comes to public regulation of the space. Right. So when you think about transparency and explainability, this is from an ethical perspective. This is let's say a guiding principle everybody agrees to. We have to be transparent. We have to be explainable. And when you think about it in terms of foundational models, now let's take large language models. A lot of the information that or there's not a lot of information about the training data and model architectures that are running underneath many of the models that are out there. And when we have information about that, because it's a self-supervised process, even the people who are training the model don't have full information about what the data contains. That's why we can have these large language models, because we don't have to look into that. It's not bad will of the people who are training the model, but that's basically the reason why it's scaled, why we see this large language model. Self-supervision is the key to that. And obviously, because these models are growing in their size as well, it's getting harder and harder, and in my opinion, basically almost impossible for any human to understand for a single input why a certain output has been generated. You can reason about it, of course, but to say, I understand why this happened is very hard. It's all the things that we see, they're deterministic, so we can, if we would have enough time, like 100 people working for 100 years, with a calculator, you can calculate all the equations and get to the same results at the output. In that sense, it's explainable. You can show the code, you can show the weight, but what it means is very hard to provide, right? When it comes to bias and discrimination, I already explained. For foundation models, we have these uncurated data sets that we're using, right? People who are providing that commercially, they don't tell you exactly how they're doing it, and they also have curated data set, but a lot of it is uncurated data sets that they scrape from the internet or get from other sources, and we cannot assume that they are balanced, right? So just thinking about who has access to the internet in Europe, in Africa, South America, North America, Asia, how much input there will be on internet from each of the different locations already tells you, okay, it cannot be a balanced data set if you scrape the internet, put it in there in training. Still, it's superior than anything that we have had before that, right? Don't get me wrong. Probably also in terms of bias and discrimination, it has superior properties, but we cannot prove that in the way, and we cannot safeguard it in the same way anymore. And detecting bias in unstructured data, like in images, in text, is much harder than it is for tabular data, for time series data, for classifications where it's black or white, or it's one of those classes, and we can determine that on predefined labels. And the last part, I would say, yes, of course, human agency and oversight is, I said we have human in the loop in all our products, but an issue that I'm seeing is that when you're asking a large language model or any other foundation model about rationale that helps you to understand why certain things have happened, to make it easier for you to then take a decision, then what these models are very capable of, as I explained to you, is to give you a good explanation. But whether that's the right explanation is obviously not, because in my node 7b, I calculated this, and that's why it's not that. It's an explanation that is sound, but it's not related to what has happened in terms of computation in the model. And we have to define for us as humans whether this is enough for us, whether a rationally sound explanation is good enough for us, basically. So if you're interested to talk more about generative AI, about how we apply it at SAP, or what are the AI ethics related considerations, please visit me at the booth. I will go there straight after this talk. And of course, if you're interested in an SAP career, you can check that out as well. You can find here the link, or join us at this employer session at 2:35. So right now. Thanks a lot.
Thank you, Sebastian. We have time for maybe a couple of questions. Does anyone want to ask a question? Please raise your hand so we can bring you a mic.
Hello.
Oh, you have the mic already. Amazing.
Yeah. So thank you so much for your presentation. And I do think that these are very important factors to keep in mind. And I just want to ask, what is the approach of SAP at the moment to address this discrimination in the data and labeling?
So as I said, we're not using large language models, and in fact, no other models as well, to do automated decision making on anything that relates to human. So I would say from an ethical perspective, it's okay to do automation of, for example, the digitization of a document, right? So even if there is bias in the sense that the algorithm would detect every 0 as an O, it's obviously we would call it a bias, or you could say it's discriminating zeros for O's. Doesn't matter, but there it's relatively okay. But we talk about discrimination when humans are involved, when humans are becoming subject of it, or if they in other areas they can get disadvantages or can get hurt and so on. And for that we have our policy that specifies that humans have to be able to overrule and to have the last say in whatever the algorithms are suggesting. Making the human responsible, giving power to the human, that's the way we're approaching this part. And of course, we're testing and measuring that our algorithms that we're training and that we're embedding are as bias-free as possible. But of course, we all know that you cannot predict what you don't know. That's why we're taking these measures.
Thank you for that. And I'm just wondering, is SAP also using AI for recruiting, for example?
Yes, we're using AI also in HR processes. What we're not doing, we're not using AI to make any decisions about candidates. But yes, when you look at the recruiting process, for example, we're using it, or we're planning to use it to create job postings. We're using it to retrieve information out of CVs. We're using AI in multiple process steps in the hiring process as well. But again, we're always having the human as the person or as the entity taking decisions. And at SAP, we're following in our AI ethics policy and review process. We follow a risk-based approach. All the HR relevant processes that are dealing with humans, which is the overwhelming maturity of these processes, we go into a review with an AI ethics steering committee and experts that we're setting up. So it's not a single decision of one product team or one person, but it's then also retro-checked by experts in our organization.
We have time maybe for one more? No? All right, so if not...
Super, all clear.
Yeah, it's super hot here. You're probably dying to get off stage and get a glass of water. How can people find you? I guess you have your...
Yes, visit us at the booth. And if you don't know where it is, you just need to follow me.
Okay, so follow him. Thank you
you
so much, Sebastian.
Thank you.